What's a residual plot? A plot of residuals. Ask a silly question, get a silly answer. A plot of residuals is when you take the data and instead of looking at the points in terms of comparison with like the explanatory and the response variable, you compare the points to where they were expected to be, above or below the line. So here we have all the various data points from the last video, and their residual size. By that I mean, there was a car that was measured at temperature 30 degrees that had a PSI about 2.5 points below what the least squares line thought it would be. Here's 40 degrees. At 40 degrees there were several cars, one of which was right on the line, and another one that was significantly below the line, another one with like 42 that was, had a PSI 1 point something above what its predicted PSI was, and so forth and so forth. 50, 60, 70, 80, 90. On some AP exams they've asked people, hey, of course on graphs more sparse than this, hey, that point with a that was recorded with a temperature of exactly 60, what was the PSI on that point? And all they'll show you is a residual chart. And you go, well, let's see, that point that you say was measured at a temperature of exactly 60, the least squares line says that that the predicted PSI was 60 times this, 1.3, 7.8. The least squares line predicted that it would have a PSI of 32.9, but in actuality it had a residual of 1, which means its PSI was 1 more than we predicted, so the actual PSI on that car must have been 33.9. So like identifying where the point was from the residual chart. So what's it used for? It's used most often to try to detect if the pattern was actually a linear pattern or not really. So consider this. In this example, let's say we first created our regression line and plotted all the points in the example, and then we took a look at the residual plot. So we took a look at each point's residual. The point at a temperature of 50 had a residual of blah. The point at a temperature of 40 had was 2 PSI below. And then we noticed that there was a pattern there. And here's what I mean by a pattern there. If you have a proper residual plot, there should not be any sort of real shape. It should just be like straight across, dots both up and down, without any sort of curve to it. The curve indicates, the fact that it changes direction like this, indicates that the points really weren't in a straight line after all, and linear regression may not be the right tool to use here. And there's stuff in chapter 12, and honestly a separate course, that would handle how to correct for this. But the main point is that it's saying that a linear model, writing a linear equation and saying, here's a good predictor, is a bad idea. Maybe it's actually parabolic, maybe it's something else, but the point is, it doesn't look linear, because when you look at the points and whether they missed above the line or below the line, there's a pattern. The ones at the very beginning all seem to miss below the line. Then they all start missing above the line, and they all start missing below the line again. That indicates that the points are not in a straight line. Let me give you one more illustration of what the residual is. See this? Any point on this line would have a residual of 0, in other words, be right on the regression line. If you have a regression line that goes through a bunch of points like this, the residual plot is almost as if you took that graph and you moved everything this way to turn this line into this line, into the new x-axis, and then compared the points from whether they were above or below that line, and then oh, this point is that point, and so forth. And so if there are a lot of points below early on and then it rises and then it falls, that's telling you that the original shape was curved. You might not see it in the original shape because it's harder to spot. It's always easier to spot when you look at a residual chart. and they'll probably have like 2 questions, maybe, on residual plots, but you'll need to understand it, what it is when you see it.